Okay. Excuse me. Now that we've gone over that, I'm going to start going over several different methods of determining the axis deviations by either the leads, looking at the positive and negative, and also those numbers we went over earlier. You can look at those too, just depending on what you prefer, or if you ever had to do it, what you're given. You may depends what you get. So I'll come around here where I can kind of point at some stuff. All right, so I'll just come right here. So we've got your basic kind of 12 lead EKG. They call this a 12 lead because it takes basically 12 different little pictures of the heart, and they're kind of hard to see, but they're numbered 1, 2, and 3. But then they're called AVR, AVL, AVF, V1, V2, V3, V4, V5, and V6. It's kind of crazy. Don't ask me exactly why it's that way. I have no idea. That's just how it is. But we can pretty much just not even look at this whole kind of right side over here. Or, yeah, that's y'all's right. This whole right side over here we're not even going to mess with. What we're mostly looking at is leads 1, 2, 3, and I believe one of the methods for determining will also include AVF. So it just kind of this corner is what we're all going to look at. So I just want y'all to know when I'm saying something about lead 1 or lead 3 or whatever, these are the ones we're talking about. 1, 2, 3, and AVF. So come back up to that. Alright, so here's kind of one method of determining the an axis deviation, looking at this uses leads 1 and AVF. So that's that one that was up here in this top corner and then at the bottom of our little corner down here. So basically, if they're both positive, so those QRS complexes are both pointing up, it's a normal axis deviation. You know, right off the bat, it's totally normal. You have hopefully no issues or anything, or at least your electricity is flowing the way it should be. So then we look at leads 1 and AVF again. If lead 1 is positive, pointing up, and lead AVF down here on the bottom is pointing down, you've got a left axis deviation. So it's kind of flowing, like it shows that this little arrow is, your electricity is kind of flowing that leftward fashion. It's not normal. So again, leads 1 and AVF. If lead 1 is pointing down, is negative, and lead AVF is pointing up, positive, you've got a right axis deviation. So it's kind of flowing, it's getting close to being backwards from what it should be, basically. Then again, lead 1 and AVF, if they're both negative, pointing downward, then you have extreme right axis deviation. And again, that's what I mentioned earlier, is almost not 100% of the time, but almost always a fatal rhythm. Your heart's doing something that is not going to sustain life. And also, again, I know we kind of hit on it a little bit, but it's worth noting again because it's a really easy and common method of just going over axis deviation. It's just looking at the numbers. And when I go to the next slide, that one I kind of was using to show you all the leads, I'll show you where that's kind of usually printed out at, and you can see these numbers that I'm talking about here. So your normal axis deviation is anything from 0 degrees to 90 degrees. And remember, that does also include that little from 0 to negative 30, that physiological left axis deviation. Even though it technically is a left, it's normal. It's nothing, you don't have damage to your heart or anything crazy. But left axis is anything from 0 to negative 90. So that would be kind of this upper quadrant, the upper quarter of the circle here. Right axis is anything from positive 90 to positive 180. Yeah, so you got this kind of bottom right quarter of your circle here. And then extreme right is anything from negative 90 to 180. And that's that top right corner. And again, that's the total opposite direction electricity should be flowing in your heart. Okay. So what it's got it kind of in this red circle here. What it says over here is P, QRS, and T axes, whatever the plural for that is. And it's got 3 different numbers. It's got your P axis, your QRS axis, and your T axis. We don't care about the P or the T axis. What we're looking at is the QRS axis right here in the middle. That number is the numbers we were looking at earlier. So I know it's probably too small for pretty much any of you to see, but this says 54 degrees. So we'll come back up. And if we take a look at our numbers, anything from 0 to 90 is normal. Is 54. It's almost right in the middle, so it's a perfectly normal axis deviation. And also you can look at the directions there all these leads are pointed. I think this last example used leads 1 and AVF. So lead 1 and AVF right here are both pointed up. It's a normal axis deviation. Okay, you can see this is labeled left axis deviation. This QRS axis, it printed out right up here. Again, I don't think y'all can see it, but it's a negative 72. So when we come back up, you'll see left axis deviation is anything from 0 to negative 90. We had a negative 72, so it falls within that range, and it's a left axis deviation. Also, we'll go ahead and take a look while we're here. Lead 1 should be positive, and lead AVF should be negative. So we'll take a look. And as we can see, lead 1, they're kind of small. This one's not the best picture in the world, but it was a good example. Lead 1 is pointing up, is positive, and AVF is pointing down. So that means it's a left axis deviation. And again, I'll go over later what stuff can cause all these different axis deviations, except normal, because normal is normal. But so right here, this person, they're probably not dying or anything, but something is wrong with their heart and electricity's flowing some weird direction it should not be. So, right axis deviation. Make up this. In a right axis deviation, leads 1 should be negative and lead AVF should be positive. Again, like left and rights are opposite, this is opposites. And also the numbers, it should be anywhere from 90 to 180. We'll take a look. So as we can see, lead 1 is negative and lead AVF is positive. So again, lead 1 is negative pointing down and AVF is positive pointing up. And also right up here we can see our numbers. Our QRS axis is 121 and the right axis deviation was anything from 90 to 180. So it's again almost smack dab in the middle. So it's textbook right axis deviation. Then again, our last one down here at the bottom, the extreme right axis deviation. Leads 1 and AVF should both be negative, and our number is going to be anywhere from negative 90 to 180. There is no negative 180, but basically it should be anything from negative 90 to a negative 179, kind of hitting into that 180. So it doesn't literally mean all the numbers all the way back around. It's that bottom corner. That's just how the axes lay out. So you can see that's a pretty ugly EKG. It doesn't look like the normal ones because, like I said, these are lethal rhythms. You are dead or dying when this happens. You do not have long on this earth if you see that on your EKG. I mean, best we can tell, they're all just kind of pointing down everything. It's just pointing down. It's all down because you're going downhill fast. So this one, I could not, for some reason, find an extreme right axis deviation with the numbers printed out on the top. But like we saw, it would be something between negative 90 and negative 180, somewhere in there. So this will be basically the same thing we just talked about. It's just going to be using a little bit different leads. So your normal, this is going to be using leads 1 and 2, and then it says, or you can use leads AVF and 3. But we'll just go with leads 1 and 2. Your normal, with normal axis deviation, leads 1 and 2 should both be positive. So again, I'm just using the same EKGs again. And you can see instead of looking at leads 1 and AVF this time, we're just going to look at leads 1 and 2. So these two right beside each other here. They're both positive, so it's a normal axis deviation. I'm not going to bother with the numbers again because we just went over that, so I'll just to which directions things are pointing. So back over here, that LAD is left axis deviation. See, lead 1 should be positive and lead 2 should be negative. So, same ones here. Lead 1 is positive, lead 2 is negative. So it's a left axis deviation. RAD is right axis deviation. Lead 1 should be negative, lead 2 should be positive. There we go. Lead 1 over here is negative, lead 2 is positive. So it's the right axis deviation. And our last one, let's didn't show extreme right axis deviation. It says intermediate axis. Extreme, which I guess is the same thing, they just use a different term.
Yeah.
Okay, so basically this intermediate axis is extreme right axis deviation, and 1 and 2 should all be negative. And it's the same EKG again. Right there, you've seen it.
Yep.
A nice ugly EKG, everything's just pointing down. So extreme right axis deviation. Another method I do not have slides for, I just kind of forgot to add them, is the method I use on the back of the ambulance real quick to determine these really quickly. Because sometimes if you don't keep brushed up on those numbers, they'll slip a little bit. I try not to rely on them just because machines can be off. I've seen them be off before, and I'll forget those numbers if I don't constantly brush up on it. So what I'll do is when I print out my 12 lead EKG, looks like this, I'll basically take it, if I'm looking at this EKG, holding it in my hands like this, I'll take it and turn it on its side, where basically these are on the bottom, all this is round up on the top, where these are pointing left and right.
Oh.
So because we're looking at left and right axes.
Uh-huh.
But before, if they're all three pointing up, I use 1, 2, and 3, all three of them right there, or 1 and 3 mostly. But if they're all three pointing up, it's normal. If they're all pointing up, it's just normal axis deviation. And again, as we looked at it, they're all three pointing down, it's extreme right. The way it becomes pretty helpful to me is determining the left and right axis deviations. So we got a left axis. When you look at it, if leads 1 and 3 need to be pointing opposite directions, not necessarily away from each other, but just not the same. When you're looking at it, they don't both need to be left or both need to be right. They need to be pointing a different direction, like away from each other or toward each other. In that instance, you know you have either a left or right. So when I turn it sideways, these are pointing away from each other. We can see lead 1 will be pointing left, and lead 3 is pointing right. In that situation, whichever way lead 1 is pointing, that's the direction of your axis deviation. So they're pointing away from each other. When I turn it on this side, I look, lead 1 is pointing left, my left, and I'm turned around, so it's y'all's left now too. It's left axis deviation. And then right axis. Again, these leads 1 and 3. Lead 1 is negative, lead 3 is positive. They're pointing opposite directions toward each other. So when I flip this EKG on the side, they're pointing toward each other. My lead 1 is pointing right, so it's a right axis deviation. Is to me, especially once you practice it a little bit and kind of get that in your head, it's so easy when it's still printing out. You can just take a glance at it and say, right, because they're pointing toward each other, it's right. Away from each other's left. All up is normal, all down is extreme right. To me, it's super simple. I don't even have to have the whole thing printed out. It can be working on printing out. I take a glance and say, oh, that's right, or that's left. I can tell what's going on just at a glance. All right. So what causes axis deviations?